This is the second lecture of our power system analysis series. You can check the link in the description to access the full playlist. And if you are new here, don't forget to subscribe and so you don't miss the upcoming lectures. All right. So let's get started. Today we will look at some examples and equations that are commonly used in per unit system to solve numerical problems. As we already know, the per unit values is simply actual value divided by base value, and remember the per unit value is always unitless because the unit cancels out. So now in power system studies we usually convert different parameter into per unit values, but the problem is the impedance of transmission line cannot be directly converted into the per unit using the same formula of actual by base. Why? This is because the base value of impedance is not given directly. We need base value of impedance which will be denoted by ZB. So that ZB is not given directly in numerical. So that's why we don't have like we will have to get some another equation to find the Z per unit of impedance. So we will derive the base impedance by starting Ohm's law. We already know that V is equal to IZ. Okay. So Z will be equal to V by I. So I am denoting B in as subscript. So it is Z base impedance value of impedance. Sorry, a base value of impedance. So Z is equal to V divided by I. Now this equation can also be written as V square divided by S. How? Let's look at this. Okay, actually I have written his. As we know, the power formula S is equal to VI. Okay, so I can be written as S over V by shifting V there. It will be divided by S. S will be divided by V. So I is equal to S by V. Now I is equal to S by V. I put this value here. So it will comes out as like this. V divided by I. So V, the I value is what? S by V. S by V. So this V will be multiplied in nominator and we got V square by S. So now we got V square by S and B is denoting the base values. So ZB will be equal to VB square divided by SB. Now you got the ZB equation to put this in the this formula Z per unit actual by base. So we got this value for ZB. So coming back to the original equation, which is Z per unit equal to actual y base. So now by putting the ZB value we derived here that ZB is equal to VB square by SB. So by substituting that value ZB here, Z ohm divided by ZB. So this will be Z ohm by ZB. If I substitute the ZB value, it will be Z ohm by VB square by SB. SB will be go up and it will be multiplied. Okay, so we got this equation Z ohm, and we can write it as this Z ohm is equal to SB divided by VB square. Now this is the final equation we will be using in the power system to get the transmission line impedance find in per unit. Okay, so impedance of transmission Z is the impedance in per unit is equal to the actual value multiplied by the base value of power we the apparent power we have. Okay, and divided by the apparent voltage. Sorry, the base value of the voltage. So this SB, which is the base value of apparent power and base value of voltage, will be selected by us. Okay, this will be selected, and it will be same for all the other parameters in the power system. Now moving forward to have a look at change of base values. Okay, so for example, we will be given with two systems, system 1 and system 2, and we will convert some old values to new values. Like if we have given with some current value, which is like in system 1, let's say the system 1 is the previous system and we denote it as old, or I have denoted as I1. Okay, so it will be I1 and the system 2 values will be denoted by 2, so I denote the current in the system 2 as I2. So the this system is the new value, so we will be going from system 1 to system 2, new from old values of system 1 to new values of system 2. Okay, this will be new, so I can write as I old I new, or I1 I2. Okay, so per unit current values in the system 1 is equal to I1 per unit, which is the system 1 value of current. So per unit formula is always actual by base, so I actual value divided by I base value. Okay, now the actual value in the both systems will be same. So similarly in system 2, I2 per unit is equal to I actual divided by I2 base. Okay, the base values will be different, the actual value will be same. So as the actual values of current are same in both systems, so we will compare both equations to get the final equation that will be used to solve in numericals, to solve the numerical problems. I actual, so we can write I actual, this is I actual is equal to I1 per unit multiply I base. It is, if we can see in the system one equation, I actual is equal to, this will be multiplied with this. Okay, so I actual will be equal to I1 per unit multiply I base. Similarly, I actual will also be equal to I2 base multiply by, it will come here, so it will be multiplied with I2 per unit. So I actual is equal to this and I actual is equal to this. Now, if we compare these equations, so I1 per unit multiply I1 base is equal to I2 per unit multiply I2 base. So we are finding the new values. So the new values is I2 per unit, or I can say I new. Okay, I new per unit. So I will leave I2 per unit as it is here, and I'll shift I2 base to the left side, and it will be divided. It will be divided here. Okay, so I2 per unit, which is there here, is equal to I1 per unit, I1 per unit multiply this, multiply I1 base and divided by I2 base. So it comes here and it will be divided by, it will get in denominator. So this is the equation we got for new value of current from system 1 to system 2. Now we know that I is equal to S by V. This is the power formula, S is equal to VI. Okay, so I is equal to S by V. So I2 per unit is equal to I1 per unit, I1 per unit multiply. Now, substituting the I value as S by V, so we write it as S by V multiply, and also we will be substituting I2 as S2 by V, so it will comes out as this I1 divided by I2 equal to S by V divided by S by V. Okay, so this is S1 V1, or this is S2 V2. So this is S1 V1, and this whole term will come up here to the right side and will get multiplied, and the position of numerator and denominator will get changed. So V2 by S2. Okay, so this is what happening here. S1 by V1, and this is base value, so that's why SB1 VB1 multiply VB2 SB2. Okay, V2 S2. So SB and VB will be selected by S, as I have mentioned earlier. Okay, by knowing the I1 per unit, I2 per unit can be found easily. If we know the old system 1 value, like we have already some value of I, like I can refer it as I old or I1, I can find the value of I2. Now there was the current in system 1 and system 2. Let's move forward on impedances. How to find impedances if we have Z old and we need to find Z new. Okay, so let's say the system 1 impedance is Z1 per unit, or I can say Z old per unit. So Z1 per unit is equal to Z ohm into SB1 by VB1. This formula comes from, as we have derived earlier here. Let me show it to you, this one. Z per unit is equal to Z ohm This is actual value, Z actual value into SB by VB square. Okay, so remember this formula. Now go back to the equation of impedance. So we know this formula is already in our mind. We have derived this one. In system 2, it will be Z2 is equal to Z ohm, means the actual value, and the same formula for system 2 also. Z2 can also be written as Z new. Okay. Now from equation 1, this is the equation 1. If I need the value of Z ohm, okay, because Z ohm is common in both equations. So I'll get the Z ohm value from here. I'll get the Z ohm equation for Z ohm from both equations, and then we will compare both of them. So Z ohm will be equal to, this is, let me find the one equation so it will be easy to understand. Z ohm multiply SB1 by VB1 square. So it will be Z per unit. I leave the Z ohm as it is on the right side and move this whole term, this term, to the left side. It will be moved to the left side. Okay. So it will be, the denominator will go up and the numerator will go down. Okay. Is equal to Z ohm. This is as it is in on its place. So Z ohm is equal to Z1 per unit VB square by SB1. Okay. Similarly, from equation 2, we also get the Z ohm equation, which is Z2 per unit VB square and SB2 square. Okay. So in the second system, equation 2 is from second system. That's why it is VB2 SB2, and the first equation is from first system. So that's why it is Z1 VB1 or SB1. Now, uh, Z ohm are same common in both systems, so we will compare these two equations. Okay, so Z1 per unit and this is equal to this. Now I need to find this Z2. Remember, always we will find, as we find earlier, ZI2 per unit. Okay, so similarly here we will also find Z2. Okay, or Z new. This one is I new. Okay, we need to find the new value. So Z2 per unit, we will leave it as it is here. So Z2 per unit as it is here, and this whole term will be shifted toward the left side. The places, the position of nominator and denominator will be exchanged by moving it to the left side. So Z per unit is on its place. VB1 square, SB1 square is on its place. This and this whole term, when we move it to the left side, so the nominator and denominator position will be exchanged. So it is SB and VB square will go down. So by rearranging, we get this equation as Z1 per unit VB1 square divided by VB2 square. So the squares are on the both voltages and common, so we will get the whole square, and SB2 divided by SB1. Okay, SB2 by SB1. So this is the equation. This is the final equation for the impedance. Finding from old system to new system. Okay, old system to new system. So I can refer Z2 per unit as Z new per unit, means this is the new value of per unit, and Z1 is as Z old per unit. So whenever we have given with the uh, impedance, let's say like this in the numerical equation, okay, and we need to find the new value of this impedance with respect to the new base value. Okay, we will be selecting new base value for voltage, we will be selecting new base value for power. So by reflecting this old value to the new value of Z, and according to the new base values of voltage and power, we will be using this formula. So this equation will be used to find the impedances. Also you can use this one. Both the equations are same, just the difference is that like we are denoting VB1 as VB old here, and VB2 is equal to VB new. Similarly for power, SB2 and SB1, and Z1 per unit and Z2 per unit. Okay, so that's it for today's video. If you have any questions, so do ask in comment section. And in next lecture, we will be solving a numerical problem. We will be using these equations to solve a numerical problem from power system analysis. Till then, take care and Allah Hafiz.